Hello everybody, today we're going to talk about graphs of rational functions. So, what is a rational function? A rational function is basically a function that is made from a fraction. So it's got a numerator and a denominator. Okay, the denominator can't be zero. Okay, and what you're going to want to do to graph these things is you're going to want to follow a process, and it's really pretty simple. First thing you want to do is you want to simplify the equation as much as possible. So you want to factor it down because that's going to give you a lot of information about the graph. Okay? You're going to want to graph the Y-intercept. You're going to set the numerator equal to 0 so that you can find the zeros, okay, the x-intercepts. You're going to find the zeros of the denominator if there are any. And that's going to tell you where the vertical asymptotes are. Okay? You're going to look for any other asymptotes you might have. So you're going to use your properties of degree to tell, does it have any horizontal asymptotes? Does it have any oblique asymptotes? You're going to put those on the graph. You're going to want to graph a couple of points on the graph, and then you're going to want to sketch it. Okay? So here we go. Sketch the graph of each function by hand and compare it with the graph of f of x equals 1 over x. So I would actually probably do these by transformations because I know what the graph 1 over x looks like. Okay? Obviously, it cannot be x can never be 0, so this doesn't have a y-intercept because it's got a vertical asymptote at 0. Okay, so we got a vertical asymptote right there. I can't cross that vertical asymptote. Now 1 over x, if I put in a number, the bigger the number the gets, the smaller this fraction gets. So as I go further and further away from the x-axis, this number becomes smaller and smaller and smaller. As I get closer, it gets bigger and bigger and bigger. So the graph looks like this. And I actually know that it passes through the point 1, 1. Because if I plug in 1, f of 1 is just 1. On this side, it passes through the point negative 1, and it does this. Okay, so there's the graph of 1 over x. Now this, right here, since I'm adding a number inside the function on the denominator, that's just going to move this thing 2 to the left. Okay, so it's going to move. This, by the way, this had a horizontal asymptote at 0 too. Okay, so now if I look at this one, it's going to have a horizontal asymptote at 0. Now, why is there a horizontal asymptote? Well, because remember, if the rule is it has a horizontal asymptote if the degree of the numerator is less than the degree of the denominator. So the degree of this numerator right here is 0. The degree of the denominator is 1. So since the degree of the denominator is bigger than the degree of the numerator, that means this thing is going to shrink to 0. It's going to have a horizontal asymptote at 0. So if you think about it, what happens as x goes to infinity here? Okay, this number on the bottom gets bigger and bigger and bigger. This stays the same. So the number as a whole gets smaller and smaller and smaller. This approaches 0. That's why you got a horizontal asymptote there. Now it has a vertical asymptote at 2 because that's where the denominator is 0. So just like this, okay, it was just shifted 2 to the left. All right, the point 1, 1 is a key point. It's going to get shifted 2 to the left. The point negative 1, 1 is going to get shifted 2 to the left. And then this thing's going to look like this. Oh, except for one thing that I forgot. It's negative. Okay, I've got a negative here that's going to flip it upside down. So actually what's going to happen is this point's going to get moved 2 to the left, and it's going to get moved down here. And this point is going to get moved 2 to the left, and it's going to get moved up here. So this graph's going to look like this. Remember, you cannot cross a vertical asymptote. You cannot cross it. So that's going to look like that. Now this one here I can do by transformations as well. This one gets moved 1 to the right and 3 up. Okay, so I'm going to take my asymptotes and I'm going to move it 1 to the right. So the vertical asymptote, what happened here? Vertical asymptote that was here gets moved 1 to the right. So it's going to be right there. And then the horizontal asymptote was at 0. It gets moved to 3. Because everything about this graph gets moved 1 to the right and 3 up. Now this doesn't have any negatives in it, so the point that was normally at 1, 1 gets moved 1 to the right and 3 up. It goes here. And -1, -1 gets moved 1 to the right and 3 up, so it's right here. So this graph's going to look like this. And there you go. Okay, let's sketch this graph. G of x equals 3 over x minus 2 by hand. So, first thing we would want to do is factor it. It's already factored. I can't factor it any further. Okay, I'm going to look at, I know this thing has a horizontal asymptote. I'm going to write this stuff down as I go. It has a horizontal asymptote at y equals 0. Okay, so I'm going to go ahead and put that right there. Why does it have a horizontal asymptote at y equals 0? Because the degree of the numerator is 0 and the degree of the denominator is 1. So this is going to grow much faster than this is, and this is not going to grow at all. It's going to stay 3 all the time. This is going to get bigger. So this fraction as a whole is going to turn into 0 well, it's never going to be 0, but it's going to get as close as you want to 0. So I've got the horizontal asymptote there. Let's make this the same color. Okay. Now, does it have a vertical asymptote? Well, is the denominator ever 0? And the answer to that is yes. Okay, so x minus 2 equals 0 implies that x is 2. So this has a vertical asymptote at x equals 2. Okay, so we'll go ahead and put our vertical asymptote on there at 2. Okay. Now, does this have a Y-intercept? That's always something you want to find if you can. And I'm going to find that by finding g of 0. And that would be 3 over 0 minus 2, or negative 3 halves, negative 1.5. So yes, negative 3 halves is going to have a Y-intercept right there. Will it have an x-intercept? Well, x-intercepts would come from the numerator, when the numerator is 0, and the numerator is always 3. So this has no x-intercepts. Now, I can really tell what this thing's going to look like. I could sketch it very quickly right now. I know it's going to look like this. It's going to want to approach this here. It's going to go like this. It's going to go through here, and it's going to turn and go to the asymptote right there. Okay, now, the next thing, which the rule people forget, is the rule for asymptotes. So the degree of the asymptote tells you what happens at the asymptote. So this is x minus 2 to the first power. It's an odd asymptote, which means it's going to go up on one side and down on the other. Now, it doesn't tell you which one. You have to figure that out. Okay? But if this was x minus 2 squared, the degree would be even. It would either go up on both sides of the asymptote or down on both sides of the asymptote. But this one is odd, so it's going to go down on this side, which means it has to go up on the other one. Okay, so this is going to look something like this. Now, I would like to have a point over here. So look at this. If I can go 1, 2 to the right and 1.5 down, I go 1, 2 to the left and 1.5 up. That point right there is going to be on the graph. This thing's going to be symmetric to this point right here. So this is going to look like this. And there's my graph. Make sure you show this work over here too. Okay, moving on. Example 3. Sketch the graph f of x equals 2x minus 1 over x by hand. Okay, so it's already factored. I don't have to worry about that. It does have a vertical asymptote. So it has a vertical asymptote at x equals 0, because that's when the denominator is 0. Now, unfortunately, since it has a vertical asymptote here, it's not going to have a y-intercept at 0. Now, let's check for horizontal asymptotes. So I check the degree here is 1, the degree here is 1. Oh, the degrees are the same. So basically, these things grow at the same rate. Okay? So when the rule is when the degrees of the numerator and denominator are the same, then you take the leading coefficients and you divide them. So this would be, it's going to have a horizontal asymptote at the quotient of the leading coefficient. So that's going to be 2 over 1, so it's going to be y equals 2. Okay, so I'm going to get a horizontal asymptote right there. Okay. Like I said, since it's got a vertical asymptote at 0, there's no y-intercept. But there is an x-intercept, and I can calculate that because the numerator, 2x minus 1, will equal 0 when x is 1/2. Okay? So right there, we've got an x-intercept. And now I know what the graph looks like, because it has to approach this right here. It's got to approach the vertical asymptote. It can't touch that, so it's going to come here. It's going to pass through that point, and it's going to approach that asymptote right there. Now, I know that this asymptote is odd multiplicity. I think I said degree before. It's odd multiplicity, sorry. So that means it's going to go down on one side, it's going to go up on the other one. And I can actually locate a point from here. If I go down 2 into the right 1/2, I can go up 2 into the left 1/2. It's going to go through that point right there. And there you go. So there's that graph. Okay, let's look at this one. This is one that we're going to have to factor it. And let's go grab a graph back here. Okay, so there we got a nice graph. So let's take this thing, f of x, and we're going to factor it. Now the numerator I don't have to do anything to, but the denominator factors of 2 are 2 and 1, and I want negative 1 in the middle, so it's going to be minus 1 and plus 1 and minus 2. So this is factored, and now I can tell a couple of things. This has 2 vertical asymptotes. So it has vertical asymptotes at x equals negative 1, because that makes this 0, and positive 2, which makes that 0. Okay, so we'll go ahead and put the vertical asymptotes on there. There's one. There's the other one. Now, this thing has a degree 1 on the top and a degree 2 on the bottom. So the bottom's going to grow faster than the top. This thing's going to have a horizontal asymptote at 0. Horizontal asymptote at y equals 0. Okay, next, does this have a y-intercept? So f of 0. Well, that would give me 0 on the top. And the bottom would be 0 squared, which is 0, minus 2, negative 2, that's going to be 0. So this thing has a y-intercept at 0, 0 right here. Okay. Now, unfortunately, I don't have any x-intercepts other than that, because if I set the numerator equal to 0, I just get the same thing. It's the same point. Okay. So here's what I got to do. I got to find another point. So I'm going to find the point f of 1, because it's pretty easy to find. Okay. So that's going to be 1 over 1 squared, which is 1 minus 2, which comes out to be negative 1/2. Okay, so f of 1 is negative 1/2. That goes right there. Now I know what this graph looks like now. I can tell you what it's going to look like. Because since it crosses here and goes here, there's no other 0 in here. This thing has to go to the asymptote, and it can't go this way because there would be another 0 over here. Likewise, this thing can't come back to this asymptote. It's got to go above and approach the asymptote here. So there's what the middle section looks like. Okay, now what do the ends look like? Well, this has a multiplicity of 1 at negative 1. So that means it goes up on one side and down on the other. That means this is going to go this way. Now I'd like to have, if I just needed a rough sketch, I would just sketch that in. But let's find f of negative 2 real quick, and that'll give us a little more accurate graph. So that'd be a negative 2 on top. This would be 4 plus 2 minus 2. So this is it's going to be negative 1/2. So that's going to go right here. So this graph's going to look like this. And it's going to go like that. Now over here, the other asymptote has a multiplicity of 1 as well. So it goes down on this side, it has to go up on this side. And, depending on how accurate I need to be, I can just sketch this in. Or if I needed to be a little more accurate, I could find f of 3. So that'd be 3 over 9 minus 3 minus 2, which would be 3 over 4. So 3/4. So this thing's going to look like this. And there's my graph. I'm done. All right, let's look at this one. Oh, now with this one, we get to factor the top and the bottom of this thing. So we're going to start out with f of x. Let's see, x squared minus 9. That's a difference of 2 perfect squares. So that's going to factor to x minus 3, x plus 3. And then the bottom, I get an x and an x. I get a 3 and a 1. And I need a negative 3 and a plus 1. And you know what? I need a graph. So let's go back here and let's clone that graph. And we'll cut and paste that onto the next page here. Okay, there we go. All right, so now check out what happens here. The x minus 3 cancels the x minus 3. Now what does that mean? That implies there is a hole in the graph at x equals 3. Now here's the problem, is I don't know where that hole is, and that's the first thing I found. Okay, and it's probably the last thing I'm going to be able to graph. I can't forget to go back and do that. Okay, so I just got to remember, I got to come back and I got to put the hole in it. It's got a hole at x equals 3. Anytime something cancels like this, there's going to be a hole there, not an asymptote. Now, this is going to have a 0. It's going to have a 0 at x equals negative 3 from that. So I can go put that on the graph. It's going to have a vertical asymptote at x equals -1 from this, so I can go put that on the graph. I can see that this has degree 2 and that has degree 2. So that means there's going to be a horizontal asymptote. And I'm going to take the coefficients, which are 1 and 1, and divide them, which is just 1. So this is going to have a horizontal asymptote of 1. Okay. So I can almost graph this. I could actually graph this thing right now, depending on how accurate I need to be. Because this thing's going to go like this, and it's going to go like this. Okay. And I know that because this has a multiplicity of 1, so it's going to go down on one side, it's going to go up on the other. It has to go down on this side because I'm below this. I don't have any x-intercepts to come up. All right. I need to approach the asymptote on both of these. So it's got to do, oops, I want red. It's going to approach here, and then it's going to go like this. Now, the only thing else you might do is you might plug -2 in here and figure out what this point is so you're a little more accurate. Okay, does this thing have a y-intercept? Sure. So I can find f of 0. So that'd be 0 minus 9 would be -9. And 0 minus 0 over minus 3 would be -3. So that's going to have a y-intercept at 3. So that's going to go right here. And so now I know this graph is going to look like this. It's going to come here. It's going to look like that. Now, this is symmetric to here, so if I go up 1, 2, and to the right one, I get the y-intercept. So if I go down 2 and to the left one, so I kind of missed just a little bit right here. It's going to go through that point right there, so it's going to go like this. Now, I can't forget my hole. I got to go back and put my hole in this thing. So I'm going to go to x equals 3, and there's going to be a hole right there. So then I'm going to put just a little circle right there like that, and there's my hole. Now, this graph looks exactly like this graph, except this one has a hole and that one doesn't. Okay, this one that got canceled out. This one doesn't have a hole because there's nothing to cancel. All right, moving along. So oblique asymptotes. How do you get an oblique asymptote? If the degree of the numerator is exactly 1 bigger than the degree of the denominator, then there exists an oblique asymptote. So I look here at this one. The degree of the numerator is 2, the degree of the denominator is 1. That's exactly 1 more. So what I'm going to do is I'm going to take x squared minus x, and I'm going to divide that by x plus 1. Okay, x goes into x squared, x times x is x squared. X times 1 is x. I'm going to subtract those two things. Okay, I get 0, I get -2x. X goes into -2, x -2 times, and that's -2x minus 2, and I subtract those two things, and I get a remainder of 2, and I don't care about remainders. Remainders disappear as you get close to the asymptote. So I'm only interested in this. This tells me that there is an oblique asymptote at y equals x minus 2. Okay? So I had to do quite a bit of work to find it. Not too bad, but more than the other things. Okay, so I'm going to go ahead and put my oblique asymptote at x minus 2. So that's going to have a slope of 1 and a y-intercept of 2. It'll look like that. There's my oblique asymptote. Now, this will also have a vertical asymptote at x equals -1, because that's when the denominator is 0. So I'm going to go ahead and put that asymptote in there. So we got that. Okay, I should have factored this thing right off the get-go. So this would be x times x minus 1 on the top, and it'd be x plus 1 on the bottom. So there's no holes, fortunately. And it's going to have zeros wherever the numerator is 0, which is going to be at 0 and at 1. So this will have x-intercepts at 0, 0 and at 1, 0. Okay, so we go ahead and put those on 0, 0 and 1, 0. Okay, now I know what this graph is going to look like. Okay, it's got to go to this asymptote, and it's got to go to this asymptote. So this thing's going to come down here like this. It's going to cross here. It's going to cross here. And it's going to approach that asymptote right there. Now, this is going to be symmetric to this right here. How do I know that? Well, there's no zeros over here, so this can't go like this. And also, this has an odd multiplicity, so it's got to go down on one side and up on the other on the vertical asymptote. So this thing can't go like this because it'd be going up on both sides of the asymptote. So this is going to look like this. If I want to locate a couple points, I could start here, and I could go up 1, 2, 3 into the right 1, so I'd go down 1, 2, 3 into the left 1. Those points should be the same, and then that should be the same as this one. So this graph is going to look like this. And there you go, you're done. Okay, let's check this one out. So this one's going to have a, let's factor the top. We'll do this, we'll make sure we do this in the right order. So f of x, x minus 1 on the bottom, we got x and x, we got 2 and 1. We've got minus 2 and plus 1. So nothing's going to cancel. There's not going to be any holes in this graph. We are going to have a vertical asymptote, though. At x equals 1. So we'll go ahead and put that on there. And we're going to have an oblique asymptote because the degree of the numerator is 2 and the degree of the denominator is 1. So we got to calculate that. So let's do that. So that's going to be x squared minus x minus 2 divided by x minus 1. So x goes into x squared x times x is x squared. X times negative 1 is negative x. Subtract. Both these cancel out. I'm left with negative 2. Okay, that's going to be my remainder. I don't care about the remainders. So this is going to have an oblique asymptote at y equals x. All right, so y equals x is going to go from here down to here. Okay, is this thing going to have any zeros? Well, yeah, it's going to have some zeros. So it's going to have a 0 at negative 1. So zeros at negative 1, 0, and another one at 2, 0. Okay, so negative 1, 0 is right here, 2 zeros right here. Is it going to have a y-intercept? Yes. So if I find f of 0, that's going to be 0 minus 2 over 0 minus 1. That's 2. So I can put that point on the graph. And now I know exactly what this graph's going to look like. Okay? It's got to go through these 2 points. It's going to do this. Okay? Now, I've got this here. This is going to go like this. And, you know, if I wanted to go from here, I go, to the left one and up one. So if I go to the right, nope, I can't do that here. Oh, that's that. So if I want to go down 2 and to the right 1, or to the left 1, I can go up 1 to the right 2. It's going to go through that point right there. I just kind of missed this just a little bit. There we go. All right, there's my graph. Okay, a rectangular page is designed to contain 48 square inches of print. The margins on each side of the page are 1.5 inches wide. The margins at the top and bottom are each 1 inch deep. What should the dimensions of the page be so that the minimum amount of paper is used? Okay, so first thing you're going to want to do here is sketch a picture. Okay, so I'm going to have some kind of rectangle, and I know that the writing is going to be here, and then the paper is going to look like this. It's going to have 1.5 inches here, and 1.5 inches here, and it's going to have 1 inch here, and 1 inch down here. Okay, now the thing is, I don't know what these are. Okay, so we're going to call this X right here. We're going to call this Y right here. And I do know one thing. I know that the area of the print is 48 square inches. So I know that the area is X times Y here. And so that 48 equals X times Y. Okay, now, I need to find the area of the paper. So I need to know this distance. Well, that's going to be y plus 1 plus another 1, so that's going to be y plus 2. And the base here is going to be x plus 1.5 plus 1.5, so that's going to be x plus 3. So I get a formula. Area is going to be x plus 3 times y plus 2. The problem is I've got two variables in one equation. But wait, I have another equation over here. I know that x times y is 48. So I can solve for one of these. Let's solve for y. Divide both sides by x, so I get 48 over x. Now what I can do is I can take this, and I can substitute it in here for y, and I get a new equation. Area is going to be x plus 3 times 48 over x plus 2. Okay. Now, I want to graph this. So I'm going to use my graphing calculator on this. There's techniques in calculus we could do with this, but in our class so far, we're going to use technology to solve this. So we're going to go to, we're going to get our handy dandy TI-84 plus C Silver Edition graphing calculator out, and we're going to go to y equals, and we're going to type in x plus 3 in parentheses, and then we're going to add, and we're going to multiply that by, make sure you put these parentheses in here too. Okay, we're going to get those in there. Now, we have to have a window. We got to know what the window is. So, we got to pick something reasonable. So for x's, I don't know, push your window key. Let's go from like 0 to 40. And we'll make the scale, we'll count by tens. Okay, and then area is a little bit bigger, so we'll go 0 to 200, we'll count by, I don't know, tens again, we could probably do that. And hit graph. And what we get, so we get a graph that looks like, kind of like a Nike swoosh here like this. This is the area, okay? And this is dependent on my x's and my y's here. So what I want to do is I want to find the lowest point right here. So here's what I'm going to do. I'm going to go second, calculate. Number 3 is minimum. And it put my little target like right here. I want to make sure I move it so that it's for sure to the left of this bottom part. So over here somewhere. And it says left bound, so I hit enter. And then I'm going to move it using the arrow key over to here. The right arrow. Doesn't really matter where, just make sure it's beyond the minimum point right there. Hit enter again. and then it'll say guess, and have it guess, and it says that this point right here, this minimum point, is the point 8.48, 87.94. Okay, this is my x right here. This, I'm sorry, this is not y. This is my area right here. Okay, I do know what x is. X is, we'll round it to 8.5. Okay, so how big is the paper going to be? This needs to be 8.5 plus 3. So that's going to be 11.5 inches wide. Okay, now I've got to figure out what the other side is. So here's what I'm going to do. Is I know that the area, I know that x times y is 48, because we got that right here. So I'm going to put 8.5 in here. Whoops, not 4.8, 48. And I'm going to go ahead and divide both sides by 8.5. And y is going to come out to be 48 divided by 8.5. Comes out to be 5.6, rounded to 1 decimal point. Okay, so that's y. Now, I got to go over here. I got to add 2 to that because I've got this margin and this margin. So this side over here is going to be 7.6. Uh-oh. Okay, so what is my paper going to be? My paper is going to be 11.5 inches wide. Well, it doesn't matter if it's wide or if it's high because I can just turn it on its side. It's going to be 11.5 by 7.6 inches. Okay, so there we come to the end of our assignment. These are the problems I want you to do. And we've got the pages in here. And again, they're in Google Classroom where you can see nice clear pictures. And I will see you next time, guys.